Hi everyone, Mrs. Jones here. We are starting our next unit, which is chapter 6, which is linear functions. But before we dive into that, we are going to take a look at some visual patterns. This slideshow is almost identical to the packet that you're going to receive for classwork. So you'll notice that some of the questions are actually going to also be your homework, and so we're going to skip over those. And so this is just a preview of what we'll be doing in class. So on the next few slides, you're going to see patterns of all sorts of different shapes, and you are going to be asked to write an expression to represent the nth stage of each pattern. So for example, if I wanted to know how many squares are in the 100th stage, what's an expression that you could write using n, where I could plug in 100 to figure out how many squares would be in that 100th stage. So here's what I mean. Here we have a bunch of green squares. You can see based on the stage, the number of green squares is growing. And we need to figure out how many squares would be in the nth stage. So I want to write an expression using n to represent the stage number. One of the ways that you can start to organize your work is by using a T-chart or a table, which is what I've gone ahead and done here. There's lots of important information in this T-chart. We are first going to start with this 3. Notice at stage 0, you can also see it right here, we have 3 squares that we're starting with. We are going to call this value our starting value. So that's one of our important values. The other important thing to consider is to see how much it's growing by. So notice that as I increase the stage number by 1 each time, the number of squares you can see is increasing by 3. Notice up here you can see it too. I'm adding 3 squares. I add 3 squares, etc. This blue value we are going to call our coefficient. So we now need to write an expression. We need to remember using n, our variable n, which is going to represent our stage. So the expression is going to become 3n plus 3. And I know, whoops, there we go. I know, oh boy, I know that there are 2 3's here, but I'm going to help you describe or understand which one is which. The 3 here at the end is our starting value. Let's say, for instance, I wanted to know how many squares are in the 0 stage. Well, that means I would plug in 0 for n. We know 3 times 0 is 0, so this 3 right here at the end represents our starting value, which is how many squares we start with at stage 0. Our coefficient, you remember hopefully that the coefficient is the number that's attached to a variable with multiplication. Hopefully you therefore feel familiar that this 3 in front is going to be our coefficient, because that means that for each stage value that increases, the number of squares is increasing by 3. I would like you to pause the video here and try this one on your own. Okay, you are back. So hopefully this feels good to you. Hopefully you made a T-chart. Hopefully you saw that your starting value is 5. And so that becomes right here. Here's our 5. Hopefully you realize that the stage is growing by 3 each time. And so that gave you your coefficient of 3. All right, let's move on and try another one. Let's look at this one. Notice here that we're looking for the number of triangles. However, stage 0 is missing. So here's what we're going to do. We're going to start with our coefficient this time, and we're going to look to see as each stage number increases, what's happening to the triangles. Well, I can see that the triangles are going up by 4 each time. So I know my coefficient is going to be 4, but I need to figure out my starting value. Notice that as the stage numbers increase, the number of triangles is increasing. So if I want to go backwards to figure out my starting value, I would subtract 1 here. Subtract 1 here to go back to stage 0, which means I now actually want to subtract 4. 4 minus 4 is 0. So in fact, my starting value is 0. So if I had stage 0 drawn here, we just wouldn't have any triangles. This then means that our expression is going to be 4n. So the number of triangles in the expression is 4 times the stage number. And if we wanted to check that, we could say, okay, well, stage 3 would be when n is 3. So 4 times 3 is 12, and that's correct. That's what we got up here. All right, let's try another one. This is similar. Again, stage 0 is missing, so I would like you to pause the video here and try this one on your own. Okay, you may have noticed something a little different this time. This time, the coefficient is negative. Notice that as our stages is increasing, actually the number of squares is decreasing. So that means that your coefficient would be -2. And when I go back up and I build back to stage 0, I would add 2 to get to 18. So if we had stage 0 drawn right here, we would have 18 squares. So your expression is -2n plus 18. Okay, moving on. Let's try this one together. Notice here that we have a whole bunch of stage numbers missing. I have stage 3, I have stage 5, and I have stage 7, but everything else is missing. So if you remember, all of the other ones we are looking at for each stage value, how much does it increase? But now instead, I have 2 stage values, and I know that it increases by 1. But I want to figure out for each stage value what happens. So what I'm going to do is I'm going to do 1 divided by 2. So I know it's 1 hexagon for every 2 stages. So if I divide that, that's going to tell me that it's going to be half of a hexagon per stage. So remember, this becomes our coefficient. So my coefficient is 1/2. And what I could do is I could go back in and I could build this, the rest of the table, right? That would tell me that this would be 6.5, this would be 7.5, and I could go backwards to figure out 0, right? I could say, well, this means I'm going to subtract to get 5.5. I would subtract again to get 5, which means I would get 4.5 for my starting value. Okay, so when I put this all together, my expression would be 1/2 n, because that tells me that for each stage value, it's increasing by 1/2, plus 4.5, which means that I started with 4.5 hexagons. All right, I want you to try this one on your own. It's quite similar. Again, we're missing some stages. See what you can do with this one. Okay, we're back. So hopefully you found out that again, it was going to be 1/2 per stage, or in other words, 1/2 for our coefficient. And hopefully you worked backwards to figure out 1.5 was your starting value, which means, go, your expression was 1/2 n plus 1.5. Okay, awesome. All right, the last type of question we are going to do is, what if I gave you, in this situation, it's actually an equation, right? Because I have that equal sign. What if I gave you equation and I want you to draw the pattern? So if you have y equals 2x plus 3, remember here that this is going to be your stage, right? So this is x, and y is going to be the number of whatever items are in your pattern. So if I have y equals 2x plus 3, that tells me my starting value is 3. So I know that at stage 0, I'm going to have 3 of something. Then it's going to increase according to my coefficient of 2, right? I'm going to increase here. This, remember, is y. I'm going to increase plus 2, which means my next thing would have 5. I'm going to increase by 2 again, which means stage 2 would have 7. I would increase again, oops, and stage 3 would have 9. So then when I go and draw it, I would have stage 0, stage 1, stage 2, stage 3, and I could draw whatever I want to draw. Let's say I'm going to draw some stars. So I would have 1, 2, 3, and then I have 1, 2, 3, 4, 5, and you get the idea and you would continue. So hopefully this helps. Again, there are a bunch of very similar questions on your homework for tonight. And if you have any questions, please don't hesitate to ask.